Greetings, everyone. Today we're going to explore solving absolute value equations and inequalities. Make note, wherever there's a pencil in the corner, you'll want to jot that down in your notes. What you already know about absolute values is that it represents the distance from zero. So for example, the absolute value of 3 equals 3 because on the number line, I'm 3 units away from zero. The absolute value of -3 equals 3. Because again, on the number line, I'm still 3 units away from zero, just on the left side. So what if we need to solve an equation that contains an absolute value? We're going to explore graphically how to go about this, as you've been graphing for the last few sections of this unit. For this first equation, using a graph to solve an absolute value equation, we're going to use the absolute value of x plus 2 equals 5. Now let's rewrite that for right now into graphing forms. Let's say f of x equals the absolute value of x plus 2. We've been doing this for a little while now. Also, you can consider that as y equals the absolute value of x plus 2, right? That's just function notation. We can write it either way. So let's start off by graphing. The plus 2 means it's a horizontal shift to the left 2. My slope is a positive 1 on the right side. Again, if you don't remember that, you can make a table of values. If I plug in -1, I get 1. If I plug in 0, I get 2. So I can prove that these dots create an array with a slope of 1 and a slope of -1. So this part is a review. Now what's new is I have equal to y, or more specifically in this example, equal to 5. So I'm interchanging the y and the 5. So I want the y-axis at 5. So where does my graph cross the line y equals 5? And in this case, if I take a look at y equals 5, I have an intersection at 3, 5 and -7, 5. So those become my solutions, -7 and 3. Is there another way to get the solutions without a graph? Of course, we can solve algebraically as well. Let's take a look at this example, and you'll definitely want to jot this one down in your notes. A couple of rules before we get started. The first is to always make sure to isolate the absolute value. Star, highlight, underline that rule, do something to make it stand out in your notes. The second step is to set up two problems, one for the negative sloping side and one for the positive sloping side of the absolute value function. Meaning, when I graph, I have a V. I have a positive sloping side and a negative sloping side. I need to account for both of those. So to start with the first rule, isolate the absolute value. I need to move that 5 over to the other side by following order of operations, and I'm going to subtract it over. Now I'm going to set up two problems. The first for the positive sloping side, the second for the negative sloping side. So I'm going to take that 5x minus 10, and it's all going to be to the negative. The first equation we set up in this case was pretty easy to solve. You've been doing equations like this for a long time now. We end up with x equals 11. Now the next equation, you can decide, do you want to distribute that negative first, or do you want to divide both sides by -1? You can choose. I can distribute the negative into the parentheses, or I can divide both sides by -1. You decide what works best for you. In this case, I would subtract 10 from both sides. divide by -5, and I end up with x equals -7. If you chose to divide both sides by -1, then you're going to add 10 to both sides, and you still end up at x equals -7. Okay, so you decide which one works best for you. So in the end, I have both solutions, x equals -7 and x equals 11. Let's take a look at another example. First step is to isolate the absolute value. And in this case, it is already isolated on the left side. Now, let's set up both equations. I'll have a 2x plus 12 equals 4x, representing the positive side of my slope. And let's also set up the negative slope. Now in this one, I'm going to choose to distribute the negative, but again, you can choose. Do you want to divide both sides by negative or distribute? Let's solve both equations. I'm going to subtract 12 from both sides. Oh wait, does that make sense in this one? It doesn't. I have a 4x on the right side. Be careful of those extra variables. So I actually want to subtract 2x from both sides. I now have 12 equals 2x. Now I divide both sides by 2, and I get x equals 6. On our second equation, I'm going to add 2x to both sides. I have -12 equals 6x. Divide both sides by 6, and I end up with x equals -2. Okay, let's take a look for extraneous solutions. What that means, I definitely want to write that in your notes. What that means is sometimes we might end up with an algebraic solution that doesn't work in the equation. Now you'll notice this equation was a little different. It was equal to 4x. Because that's a little bit different, we need to be careful. Let's check our solutions. 2 times 6 plus 12 should equal 4 times 6. If we check our work, 12 plus 12 equals 24. Absolute value of 24 equals 24. 24 does equal 24. So this is a solution. So we want to make sure that we identify that it works. If you just leave your solutions, I don't know if you check them or not. By showing this little bit of work, I know you checked it and I know it's true. And to be honest, we should always check our solutions no matter what we think, just to make sure we're right, especially on an assessment. Let's check out -2. 2 times -2 plus 12 equals 4 times -2. -4 plus 12 equals -8. Here I end up with 8. Absolute value equals -8. 8 equals -8. That is not a true solution. So I want to put a slash through the equal sign, and x cannot equal -2. Therefore, I only have one solution. A little bit of information is that with absolute values, you can have 2 solutions, 1 solution, or no solutions. So you have quite a few options. That's why you need to always check your answers. Let's take a look graphically why that is the case. Why do I only have one solution that works? If I go and I graph the absolute value of 2x plus 12, I end up with my v value. Now, if I graph the equation y equals 4x, I end up with this blue line, and I can see that we only intersect at that one point. So that is why I only have one solution, and the other solution is extraneous. Now we've taken care of some absolute value equations, but what happens if I have an absolute value inequality? Does that change my approach to solving, or what additional rules from the past, actually from last unit, do I need to consider? Let's explore an example using graphing. Now you don't have to jot this one down, but I definitely want to clarify how solving algebraically relates to graphing, so pay attention. As before, I could rewrite this absolute value of f of x equals the absolute value of x minus 2, which is the same as saying y equals the absolute value of x minus 2. And in this particular case, 4 is greater than the absolute value of x minus 2. Now on my graph, the x minus 2 means a horizontal shift to the right 2. I have a slope of positive 1 and negative 1. Again, if you don't remember why, you can always make a table of values to show how we got that exact V shape on our graph. Now, as we can see, instead of y, we have a 4. So I'm interested in the value of 4 on the y-axis, because the y is replaced with 4. Now I have an inequality. I want to know when this function is less than 4. So if I shade, I'm interested in all the values that are less than 4. All these values on the y-axis are less than 4. So where does my graph occur in that shading? My graph occurs right here and right here, not beyond those points. So if I look, this is not or equals to, notice the symbol, so these would become sort of open dots that I would consider. And that's at 6 and at negative 2. So in the past, I would say x equals negative 2 and 6, but I'm not looking for intersections, just equals. I'm looking for an inequality. So my graph now occurs between negative 2 and 6. Notice I'm using parentheses. That's because it's not or equals to. I could also represent this on a number line, and I could say that negative 2 and 6, in between those values, are where my graph occurs. Let's take a look at another example. Again, just think through this one. You don't have to jot it down. First of all, I can rewrite it as the f of x function of the absolute value of x plus 1. Again, f of x can always be replaced with y. And y can be replaced with a 3. So let's graph x plus 1, the absolute value first, which means a horizontal shift to the left 1. And I have a positive slope of 1 and a negative slope of 1. Now I have to consider that value of 3. So I'm looking at the y-axis at 3. Now this is or equals to. So we're thinking more solid lines, solid dots. Notice where the intersections occur. So I am most interested in the graph that occurs on which side of that green line. I have to decide. I'm interested, when is this graph greater than 3? My greater than values are up here. That's greater than 3. 4 is greater than 3, 6 is greater than 3. Therefore, I am most interested in this portion of the graph and this portion of the graph. So how do I represent that in interval notation? In this case, I'm interested from the point 2 to infinity and the point negative infinity to negative 4. Now this is or equals to, so the 2 gets a bracket, the negative 4 gets a bracket, and we know that infinity always has parentheses. Now notice I did negative infinity to negative 4 because we always read left to right on our graphs, very similar to domain and range and increasing and decreasing intervals. On a number line, if you were asked to represent this on a number line, you would have a negative 4, you would have a 2, and I'm going to do a bracket at 2 or a solid dot, you can decide, and I'm going to infinity, and I have a bracket or a solid dot going from negative 4 to negative infinity. So as you can see, the type of solutions that I get from inequalities can be a set of 1 numbers, a set of 2 numbers, or I can actually end up with no solution at all. Let's take a look at another example. You'll definitely want to jot this one down. To solve, the first thing we want to do is set up our 2 inequalities. Before it was 2 equations, now it's 2 inequalities. The first one you write as is. 4x plus 5 is less than 13. That takes care of the positive slope side of your absolute value. The second inequality, you want to have that negative out front to take care of the negative sloping side of your absolute value. Now we want to solve these inequalities similar to the way that we solve equations. And in this case, I end up with x is less than 2. Pretty straightforward. On this one, be careful. I'm going to distribute my negative sign, which means I'm now going to add 5 to both sides. And then I'm going to divide by negative 4. Now be careful, you have to recall the rule of when you divide both sides or multiply both sides by a negative in an inequality, what does that do to your inequality sign? It flips it around. So I actually end up with x is greater than, and you can write this a few different ways. You could say negative 9/2 or negative 4.5 or negative 4.5. I'd accept any of them. So I have 2 intervals where this absolute value is less than 13. So the first thing we're going to do is sketch our solutions on a number line. So I have the value of negative 4.5 and the value of 2. I'm saying that x is less than 2. You can do an open circle or a parenthesis at 2, and it's less than 2, so I'm going to go to the left. I also have x is greater than negative 4.5. You can do parenthesis or open circle on the number line, and it's greater than 4.5. So we can see where they meet in the middle of this number line. If we're asked to write it as an interval, parentheses, because it's not or equal to, and I'm going from negative 4.5 to 2. Let's briefly look at those inequalities on Desmos so you can understand where that comes from. As you can see, the lines intersect at the x value of 2 and the x value of negative 4.5. We want to know, when does that graph less than the y value of 13? That graph where it's double shaded, right? Where it crosses my absolute value sign. So in this case, that is true. From negative 4.5 all the way to the x value of 2 is where my graph occurs in that shaded area. Let's take a look at one more example. Let's solve for the absolute value of x plus 4 greater than or equal to 6. So start off, you want to write it as is. And you want to take care of the negative sloping side. Let's solve this one first by subtracting 4. And we end up with x is greater than or equal to 2. Pretty easy. I'm going to distribute my negative sign on this one. Add 4. And now I need to divide both sides by -1. So again, that means I'm going to flip my absolute value sign and end up with x is less than or equal to -10. So let's take a look. If I sketch this on a number line, I end up with x is greater than or equal to 2. Or equal to means bracket or solid circle. You decide how you want to represent that. And I have the value of 10. And at 10, -10, x is less than or equal to -10. So it's going away from each other. So as an interval, I am actually going to have 2 intervals. I'm going from -infinity to -10, parenthesis, bracket, and I'm going from 2 to infinity. So why do we have you sketch those solutions? Because look how easy that made our intervals. If you have this sketch in front of you, the interval becomes much more easy to see. One last little hint on why we want you to sketch on a number line. If you were to sketch on a number line your solution, and let's say you ended up with a value that went this way, and you ended up with the value that started here but with the same direction. Okay, that is not okay. That should not happen. So that's a hint that you need to check your algebra work, make sure you flip your signs, things like that. Same thing going the other direction. If you ended up with something that went this direction, and let's say another one that went that direction, that should not happen. Okay, so we want you to sketch those intervals on a number line as a way to check your work and as a way to help you write those intervals. We're going to do a notebook check in class. Now know that these notebook checks I am going to put in the grade book. In the grade book, you're just going to see a check mark. So for right now, they're not going to be worth points. But what I'm looking for is, do you have a series of check marks or are you missing check marks? And that way we can see some data on your assessments compared to your homework, compared to your note taking. So keep in mind, you will see a check mark in the grade book for this notebook check. If you have any questions, if you need any extra help on this topic, make sure you stop by and visit. Have a good one.